Good day, Math 30-1s. Last day we learned how to create the unit circle in 4.2, and today we continue that conversation applying it in 4.3 trigonometric ratios. The big points for today are to relate trig ratios to coordinates on the unit circle, so connect ratios as coordinates, so sine is y, cos is x, determine exact values for trig ratios, and identify measures of angles that generate specific trig values. So really it's a connection between angles and ratios through the unit circle. So we have a bit of a reminder that on the unit circle there is a radius of 1, and this defines an x value and a y value from some theta, where cosine is the adjacent over the hypotenuse, which is x, that sine is the opposite over the hypotenuse, which is a y over 1, or a y, and tan is a y value divided by an x value. So if you know on the unit circle from some angle the x value and the y value, you know what cos of that theta is, and you know what sine of that theta is. We'll apply this in just a moment. There is also not just primary trig ratios, SOHCAHTOA, but there are secondary trig ratios as well, and these are defined as reciprocals, or a flip of the primary trig ratios. Cosine, we say, is cos of theta. If we flip cosine and say 1 over x, we create secant. Now it is a little bit frustrating the way that the letters sort of work out, but if you flip cos, you're making something called secant of theta. Secant is SEC. It's the third letter that kind of connects it to the cos. But secant of theta is 1 over cos of theta. It's your flipping of your x value. It's the flipping of your ratio. So what you do is you flip the ratio. For cosecant, you're flipping sine, and you end up with cosecant of theta. This is 1 over sine. Good news is on your formula sheet it does actually relate these for you together. For tan of theta, there is a reciprocal or a flipped version, and this gets the symbol cotan of theta, which is x over y, not y over x. So the flipped version of cotangent is not y over x, but x over y, just like this is 1 over y and this is 1 over x. So questions that we come across on the unit circle are things like, what is sine of 210? What is sine of 210? With sine of 210, we're being asked to go to the unit circle and try to think as best we can without a unit circle what our reference angle is. In this case, it's 30 degrees. And if you know that the 30-degree reference angle is just like the first quadrant, 30-degree reference angle has a big x value, root 3 over 2, small y value, 1/2, then we can place those values here. Big x value, small y value, knowing that the x is negative to the left, y is negative going down, and the sine is the y value, so the answer should be a negative 1/2. And in fact, if we check these in our calculator, and I won't do this for everyone, but if you check these in our calculator and type in sine of 210, it should prompt a negative 1/2 like we expect, which it does. There are a lot of other ones, and being very, very careful when you're dealing with negative angles and tangent, we can apply the same kind of logic. We first ask, where is negative 60 degrees? And that is traveling clockwise with a 60-degree reference angle, which has a coordinate location which is the flipped version of 30 degrees. It's a 1/2 and then a root 3 over 2. This time, x is positive, y is negative. So for this location, tan is a y value divided by an x value. The y value is a negative root 3 over 2. X value is a 1/2. Now some of you may need to write these out in a longer form, and eventually you'll get a little bit more comfortable with it, but root 3 over 2 divided by 1 over 2 is determined by reciprocating your 1 over 2 and changing your divide to a multiply. The 2's cancel, and you end up with a negative root 3. Now you do have to get a little bit comfortable dividing fractions, but take your time and it will be okay. Tan of 3 pi over 4. Now there are some values that are a little bit more convenient than others for tan. 3 pi over 4 puts you in the second quadrant, and the good thing about tan and a 45-degree reference angle is that you have a 1 over root 2 and a 1 over root 2, x value being negative. And when you divide the same value by itself, you get a 1, but this time negative. So you'd say the y value divided by the x value, and in fact you won't really have to do a lot of extra work because it's the same number dividing by itself, and a negative 1 comes out. This should happen with every 45-degree angle. These are the moments of clarity that occur when you do lots of practice. There are a few questions to try, and I will maybe change 1 or 2. But for letter A, sine of negative 4 pi over 3, we're looking for negative 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. I talk like that's an easy task, but in radians, negative 4 pi over 3 is traveling clockwise 240 degrees. It will take a little bit of comfort. If you were to travel in the positive direction, 4 pi over 3 is 240 degrees. Traveling clockwise, 240 degrees puts you right in this location. This is the coordinate location we're looking for. We need to eventually get there without looking at a unit circle. But we have, for a 60-degree reference angle, a small x value and the large y value. We're looking for sine as your y value, root 3 over 2. In your calculator, if you type in radian mode, sine of negative 4 pi over 3, you'd end up with 0.866, something that is supposed to look a little bit familiar as you know the exact value for that ratio and the approximate value for that ratio. And again, this does continue with more decimals after. Cos of 5 pi over 6, let's change this one up a little bit and say what would happen if I said secant of 5 pi over 6. Question just went from being a little bit more comfortable to feeling a little bit more stressful. Now, what not to do is to flip your angle. Do not change your angle, ever. Do not change your angle. What you can do is discover what's happening at 5 pi over 6. So 5 pi over 6 is your 30-degree reference angle, and what comes out of here is the big x value and the small y value. Now secant is attached to cos. This is 1 divided by cos of 5 pi over 6. 1 divided by cos of 5 pi over 6. What you're essentially being asked to do is to evaluate root 3 over 2 as a flipped version. So what many people will do, instead of worrying about 1 divided by root 3 over 2, you might just say it's root 3 over 2 flipped. The final answer is 2 divided by root 3. If you really, really wanted to do your division, you could say 1 divided by root 3 over 2, flip the root 3 over 2, and get your 2 over root 3 and change it to a multiply, and you have the same answer. But secant is just the same as cos, but once you have your ratio, you flip your ratio. For cotangent, we're looking at 270 degrees, so that puts us at the bottom. This has a coordinate location of 0 left and right, and negative 1 in the downward direction. And we're looking at cotan, which is not y over x, but x over y. So it's your flipped tangent. Your x value is 0, your y value is negative 1, and there is an answer to 0 divided by negative 1, and 0 comes out. Had the question been tan of 270, and you would have had a negative 1 divided by 0, there would not have been an answer. But for cotangent of 270, you do get an answer, and that's okay. I'm going to come back to some questions about terminal arms and trig ratios at the end. But there are some approximate values of trig ratios, and I mentioned one of these earlier in the lesson, that when you see things like cos of pi over 4, many people do get quite good at saying this is 45 degrees, and the x value is 1 over root 2. You'll also see 1 over root 2 in its rationalized form. If you rationalize this, you get a root 2 on the top and a root 4 on the bottom. So you're going to see 1 over root 2 and root 2 over 2 as being the output of cos of pi over 4. If you type this into your calculator, either one of those, or you type in cos of pi over 4 in radian mode, you end up with 0.7071. So when you see 0.7071, that's supposed to mean 45 degree angle. There's a connection between that and a 45 degree angle. That only happens at 45 degrees. For cos of 60 degrees, this is when you have a short x value, you should see a 1/2 or a 0.5 come out. So 0.5 is special for a 60 degree angle, or for a 30 degree angle if you're dealing with sine. But cos of 30 degrees is the big x value, root 3 over 2 comes out. In your calculator, you'll see this is 0.866. This was for 30 degrees. Now again, this was for cos. This was for cos. So technically these could happen for a 30 degree angle as well if we're dealing with sine. But when you see 0.7071, that's a 45 degree triangle. For 0.5s and 0.866s, those are happening with the 30 or the 60 degree triangle. So these numbers should look a bit familiar, 0.7071, 0.5, and 0.866, and they connect you to these exact values. Now, there are some values that are not exact, and there are some angles that give us some messier values. If I were to say, what's the approximate value of tan of 10 degrees? Now, 10 is not on the unit circle, so we have to look at this with our calculator at this point, and look at typing in degree mode, tan of 10 degrees, enter. Now, this is not a 0.866 or 0.7071. This is an ugly answer, 0.176, about a 3. We'll do a little approximate. But that is your output for tan of 10 degrees. So 10 degrees is on the unit circle, but it's not one of our coordinate locations that we identify on it. For cosecant of 2 pi over 7, being able to evaluate that is a result of evaluating 1 divided by sine of 2 pi over 7. Remember, don't change your angle, flip your ratio. In your calculator, we would have to actually change our mode to radians, and then we get to type in 1 divided by sine of 2 pi over 7, and now this is evaluating cosecant of 2 pi over 7. Out comes a 1.2790. Often I'll end with 4 decimal places for now. So we're very accustomed to sine and cos values being between -1 and 1. So we never really saw sine and cos values like 2 or 3 or 4. But because cosecant is a flip or a reciprocal, we're starting to see cosecant and secant values above 1. And that's okay. Let's move on and start to examine some questions that are a little bit more intensive. Approximate values of angles. So what we're going to be looking at is questions like, what is the angle if I tell you the ratio? What is the angle if I tell you the ratio? Sometimes the ratios are nice, like a half, and sometimes they're messy, like this one, which doesn't appear to be a 30, 45, or a 60 degree reference, but that's okay. There's arguably 2 main steps. First, where is your answer? Determine the quadrant or quadrants the situation exists in, and then determine the reference angle, or determine the angle, and arguably maybe a step 3 that says get your angle in standard position. But let's first ask, where is or are our answers for when cos of theta is 1/2? Remember, cosine is x is positive on the right. Now, I'm not drawing these terminal arms with any accuracy. I'm only saying they're on the right side, quadrants 1 and 4. Cast would also tell us that cosine is positive and all is positive on the right side. But we can ask when cosine is 1/2, and if you, again, are really not comfortable yet, you're referencing your unit circle to say cosine is 1/2, the x value is 1/2 at 60 degrees. At a 60-degree reference angle. The answers are 300 degrees and 60 degrees, but we're eventually going to want to get to this place in radians and for values that are not as perfect as 30, 45, and 60. So at this point, we have a 60-degree reference angle, which doesn't look like I drew that accurately, and that's okay. So as we rotate around, when did we hit a terminal arm? Our first one was at 60 degrees. Our second one occurred at 360 minus 60, or 300 degrees. And those are your two answers for this question. So in fact, if you were in degree mode and typed in both of those, cos of 60, cos of 300, they both give us a 0.5. Not every ratio is going to be perfect. And what are the values when cos of theta is negative 0.6324? Let's do this once in a comfortable degree mode, and let's try this once in a messy radian mode, one that's a little less comfortable. Now, first thing to ask is, where is or are the answers when cosine is negative? Left side. Same thing for the radians, so I won't draw a picture, although maybe we'll deal with it after with a radian measure in there. So because this isn't on our unit circle as a defined coordinate location, we do have to use our calculator to do a second function cos of negative 0.6324. In degree mode, it's going to tell us 192. I'll call it 192. So this means as you rotate around, 192 degrees is not the reference angle, but in fact your first answer for the angle in standard position. To get our reference angle, we can subtract it from 180 to give us about 51 degrees as our angle in standard position, or as our reference angle. So as we determine our two answers, 129 degrees was our first rotation, and our second answer required us to take 180, add a 51 degrees, and this gives us our second answer, 231 degrees. These are your two answers. We're going to repeat this in radian mode, and it will be a little less comfortable, but still will involve the same exact steps. This time, we do our second function cos of negative 0.6324, but this time I'm going to change the mode out of degrees and go to radians. We are in radian mode. When I hit enter, it's not going to give me 129 degrees. It's going to give me the radian equivalent, 2.25. Let's call this 2.3. Remember, 1.57 is 90 degrees-ish. 3.14 is about 180 degrees. So 2.25 is, or 2.3 radian, is not your reference angle. It's one of your first answers. 2.3 radians is the first answer. To get the angle in the reference angle, we have to take pi, take away 2.3, and what's left over is 0.9. This is your reference angle. I'm going to keep this in my calculator, and I want to be able to calculate pi plus 0.9. What comes out is the second terminal arms rotation. So I'm going to take this answer, which is still exact, add in a pi, and what comes out is our second answer, 4.0 radian. These two questions were identical, but the only difference is one was done in degrees and one was done in radians. This is technically a Math 20-1 question. Because this is in radians, it's now a Math 30-1 question. There are many questions that feel uneasy when you do them in radians, but it's important to do as many as possible to get the comfort level up. We'll maybe only do a couple more and then finish off with one last conversation about getting trig ratios. So example 2 says to determine the angle to the nearest degree. Many of these are exact and many of them will not be. Sine is positive on the top, and I know the 1 over root 2 has a 45-degree reference angle. Our theta is 45 degrees, and as we rotate, a 180 minus 45 is 135 degrees. In the near future, we are going to be asking for coterminal angles with these two arms. So right now, I wasn't told what mode to do this in. Down below, I'm going to be told, hey, this is in degrees. Hey, this is in radians. This is in degrees. And we'll be told what mode to do this in. But it did say determine the angle to the nearest degree. In the near future, we will be asked to determine all angles if there's no solution given, or no domain given. So in the future, you'll be asked to say 45 degrees, and every rotation, every multiple of 360 going forward or back. In the future, again, you'll be asked to also get the 135 and every rotation on that arm. This is what the future answers will look like if no domain is given. But for now, we're just trying to say 45 and 135 and feel safe. I'll only do maybe one more of these, and I want to look at a question that's a little bit different, letter C. Secant of theta is 2 over root 3. Remember that secant is tied to cosine, and if we flip this statement, it goes from looking incredibly uncomfortable to flipping the ratio and seeing cos of theta is root 3 over 2. These are the exact same question. One is a secant, one is a cos. As we examine where the answers for cosine or secant are both positive, that occurs on the right. X is positive on the right. Cosine is the big value at 30-degree reference angles, but this time our domain doesn't say 0 to 360, which would give us two answers. Instead, we're being asked to travel to negative 180 and to travel to positive 180. We're still going to have two answers, but this time our angles are not going to go up to 360. Our first answer is going to travel in the negative direction until 180. Do we hit a terminal arm? Yes. We hit one at negative 30 degrees. We hit another angle at positive 30 degrees. These are the two answers to today's question. As the domains start to change, and as the secondary trig ratios start to show up, questions can again feel a little strange, and that's why it's important to do lots of practice. For our very last question of lesson 4.3, we can also be asked to create trig values, so creating trig ratios for points not on the unit circle. I've got a point, negative 4, 3, which is traveling 4 to the left, which is technically off the page, and 3 up, which is technically a lot farther, but I'm just simply going to say it's somewhere up about here. And the triangle could technically be drawn, but this is a terminal arm that just sort of extends. It does have an angle that rotates, but it's saying negative 4 is the length to the left, 3 is the length going up, and this is in fact a 3, 4, 5 triangle. If you do Pythagoras, 5 does come out as the hypotenuse. Question is, what are the exact values of the trig ratios? So defined as some theta as a reference angle, I could quite simply look at some of these and say, well, sine of theta is the opposite over the hypotenuse, 3 over 5. Cos of theta is the adjacent over the hypotenuse, negative 4 over 5. And tan is your opposite over your adjacent, 3 over negative 4. And usually the negative just sort of needs to be on top or bottom or hanging out in front, but I'll leave the negative 4 as it kind of sits. These are the primary trig ratios. The secondary trig ratios are defined as a flipped version of each of these. Sine is connected to which one? Secant, cosecant, cotangent. It is cosecant of theta, and we flip the 3 over 5 to a 5 over 3. Cos flips to become a secant of theta, and this flips from a negative 4 over 5 to a 5 over negative 4. Negative could be anywhere, top or bottom. And the tangent becomes our cotangent of theta, and it flips to a 4 over 3 with a negative somewhere in there. Most of today's lesson involved determining angles from a trig ratio. Sometimes your secondary trig ratios showed up, sometimes your domain can change, but this is the heart of today's lesson. Being able to get ratios, being able to get angles from ratios, whether exact or approximate. Good luck.